repositories, or a lot of different, areas of biomedical research. But our hope is that repositories can kind of use what's helpful for them and, they don't have to necessarily worry about the rest. But the full document is available on Zenodo. There's a link at the bottom, or you can reach out to me or really anyone on the team if you have questions or want access. Essentially, we have focused on 5 major elements listed on the slide here. The first one is the NIAID minimal metadata schema. So these are NIAID relevant metadata elements. They're organized into a schema, and we've sort of recommended some formats. But already, as we've worked with repositories, folks are finding, they might already have these things, and, that's a sort of mapping exercise and a little bit out of the scope of this, obviously. The next section is persistent identifiers. So identifying identifiers, things that will help link these different metadata schemas and make it obvious the information that is within them. The next section is APIs for metadata. You'll hear a lot about APIs, obviously, in the next hour or so, but essentially we're talking a lot about exposing metadata since this is useful for finding data. I'll stop there and I'll pass it to Doug in a minute. The next section is about citation guidance. This is essentially for repositories to say, if you use data from my repository, please indicate that using the following. This makes it easier to reproduce findings, give credit to folks who've generated the data, and so on and so forth. And then the last section is outreach and training. So obviously we are reaching out to the community in these webinar series. We also have ongoing work with these repositories. So if any of those folks are on this call, thank you again, obviously, for your continued support. And we will have more webinars. So I think there's a slide at the end. So heads up for that if you're interested, but you can always reach out to us if you're interested in learning more. And that's just about it from me. So I will pass it to Doug to share more about APIs.
Great. Thanks, Christine. Thanks, Lisa. So my name is Doug. I'll be your guide for the rest of these slides for the most part. And just want to talk a little bit about what we're kind of focusing on for this day. So one of the things we're going to be talking a little bit about is just the relationship between APIs and the web architectural standards. So we'll be talking a little bit about URL structures, how that affects caching, versioning, and elements like that. Obviously, throughout this whole talk, we'll be kind of hitting the FAIR principles, the FAIR elements of APIs and how they apply in that context. And then additionally, we'll talk about things like OpenAPI, Swagger, and we'll even touch on things like Model Context Protocol and stuff like that near the end of this presentation. In terms of the audience, so we've really tried to target this at a broad spectrum, and that's difficult in a technical talk, right? You have a situation where some people are coming in and they may know a lot about APIs, developing them, deploying them. Other people want to come in and learn about them. And we do have quite a spectrum of experience we got with the polls that people took when they registered for this. And so we'll really kind of start with some introductory concepts and then try and move into some of the more web architectural based elements as we progress through this talk. About halfway through, we'll also do a quick poll just to get some feel for some additional questions on how the audience feels and some of the awareness they have and some of the types of data that they're working with. So there is a couple different elements to this talk as well, because we knew we would have this big spectrum of users. And also just to help in terms of what to talk about, there is an actual GitHub repo associated with this repository. And there's also a Colab, Jupyter Notebook actually, that you can launch into Colab and just explore a little bit more. So if you're more technical and you want to play around with some of those things, feel free to jump in. I'll just drag this across here and hope this works okay. So this is the GitHub repository that's available. And so we just have everything that went into making this slide deck is inside here. There's also, if you go into the code section and the links there on the screen, and I think Julie's going to share some of these links in the chat as we're going through this, but you can launch this Jupyter Notebook inside Google Colab. Hopefully it works well for you. We've tested it. It seems to be working okay. I would recommend if you do look at the Colab, hit run all, because loading up these initial import requirements into the system takes a little bit of time. So you may want to just tell it to run all the slides or excuse me, all the cells and go from there. And then additionally, not to scare anyone, but there's a lot of links in this presentation. And I didn't want not being able to explore them even as we're giving the presentation. So there's also this URL that'll be shared that shows all the various links that are in the slides here. And the slides will also be made available at this repo and to whomever wants to have them. So given all that, we'll go ahead and kind of start with a little bit of backstory on APIs. So I did a little research on the history of APIs. I have to say it's kind of shocked me a little bit. I knew they've been around for quite some time. The term API first kind of originated in the 1960s, but actually the concept of an API is really around from the late 40s and early 50s. It was really seen early on that you needed to be able to abstract between different applications running and provide ways for them to interface with each other. So APIs themselves as a concept have been around for quite some time. In this presentation, we're really going to be talking though about APIs as realized over the web. And so these are sometimes called web APIs. Um, if during this talk, I'll probably just refer to them as APIs, but know that I'm pretty much always going to be talking about web APIs in this presentation. One of the common terms you may hear then with regards to APIs is REST, representational state transfer. So this is Roy Fielding's 2000 dissertation. And what that dissertation really did was provide the foundation for how we really kind of see a lot of web APIs leveraging web architecture. So things like the error codes, the caching ability, all these types of things that we're going to talk about during the context of this presentation, really kind of come out of that REST style approach. And there's various degrees of implementation for that, and that's fine. There's a wide range of APIs and approaches. There's GraphQL and SOAP and other types of ways that this stuff has been done. But again, we'll be focusing mostly on web APIs and REST or RESTful type approaches. Now, in truth, you probably don't go a single day without interfacing with APIs, right? So whether you're getting your weather, whether you're calling an Uber, whether you're ordering food, or as in this example here for flights, a lot of times we're dealing with APIs and they kind of become that digital middleman. If you're traveling, you would leverage something like Kayak or something else, Google Flights. They don't hold all the information about all the flights from all the providers. Rather, they use APIs to call out to those and pull back resources, pull back flights in this case, that align with the parameters that you put in, right? The days I want to go, the hour of the day I want to leave, where I want to sit, how much leg room I'm going to get or not, these types of things, right? And so really APIs are, really just all around us, and we're seeing them all the time. And a lot of times we're interfacing to them, though, through these kind of web UIs in that context. So if we look at then APIs in the blueprint, right? And I won't spend a huge amount of time on this because these are all details that we're going to go into then in the following slides. But we are going to talk about, different ways in which metadata can be encoded or just data in general. We'll talk about the structure of the URL and the impact that can have on things like caching or persistence or maintenance of those. We'll talk a little bit about HTTP methods and how that changes things a little bit. And then also documentations of APIs and what we can do with those kinds of documentations. So, so that'll be kind of the foundation of the slides that we go through then following here. So let's just kind of dive into it then. We'll start exploring the properties of the request response sequence. So when you are dealing with a API, you typically send a request and you get some kind of response back from that request. And this is really very analogous to what you'd see then if you were dealing with a web page, right? for this presentation, or if you went to the GitHub repo, you're putting in a URL, you click go, and your response is seeing that web page. And that web page is actually being constructed by a whole series of calls that are going over that same web architectural structure that we're talking about here. And so this is two examples of the same call, right? So in this case, and I left this up kind of intentionally. Now this looks a little onerous, right? A little intimidating, but it's really just utilizing a package, a program called curl, to access a URL and retrieve back then the information that's associated with that. If you took that same URL that's here and dropped it into your browser, you would get the same exact response, right? So same request, same response. A part of that is because we're using a method here called get, and we'll talk a little bit about those methods in just a second. That is the kind of method that is typically used to retrieve resources, both in this case for an API and also when you're browsing a web environment. There's other types of methods, and I said we'll just talk about those in just a little bit. But what this kind of shows is that APIs really are mostly just URLs that return formatted data versus, say, an HTML page. So, as mentioned, we see these things daily. We use them in a browser. There are different clients then that we would typically use, right? So your browser might be a client for a web page, but we also have things like curl, the examples that I'm giving here, HTTP or Postman or Bruno, which is the example that I show up here in this image. These are all just different ways in which you can interact with those APIs. And so they provide, in the case of like Bruno, a nice environment in which you can explore, change parameters, look at how the response is coming back, and kind of see what's going on. Typical methods would be things like get, like we talked about. There's also post. So the post method is when you're trying to send information up. For example, when you submitted the sign up form for this webinar, that was probably a post call, right? Where it took the information that you put in and sent it as a package to an API that then responded to it in that regard. So again, just kind of looking at the different ways in which the APIs work and operate. So this one's kind of intriguing. We talk about APIs and web architecture, and we're talking about, for example, the way that we approach that for metadata. And I should have mentioned a little bit earlier when we were talking about APIs and we're talking about metadata, that in reality, a lot of what we're going to discuss here today is really just kind of generic guidance for APIs. And as such, whether it's metadata, images, CSV documents or things like that, a lot of these same general practices and approaches to how we do this kind of stuff is completely applicable here. One thing I really wanted to show, though, is that when we're talking about especially exposing metadata, and we'll see how well this works here for me, we can take a look at how this can be done in different environments. So for example, clicking on that takes me to this import page with information about this particular record. Right? So if then I click on this, what I've done here is this is a schema.org validator. And what it's done is it's brought in that page that we just looked at. But in reality, it also looked inside that page and found that there was an embedded bit of information in there in JSON LD, right, that is the metadata about that page. And you can actually find that down here where it's embedded in this part right here. Well, that kind of jumps around. And so we'll be talking a little bit about this in just a little bit as we move on to formats and things like that. But here, what you can see then is that I can actually programmatically extract information from that page. And so this is actually a really wonderful way to expose metadata, utilizing web architectural approaches that align completely with the API guidance within the blueprint. And it's a great way to also allow other organizations like the Google Dataset Search and other things like that to find and index this information as well as the NIAID Discovery Portal, which we'll talk a little bit about later on in this presentation. So basically here talking about how exposing a resource on the web through method get as a web page, but with embedded structured data is a wonderful way to expose metadata as well. When we talk a little bit about the URLs that we would use for APIs, one of the things that we want to think about is how we structure those APIs. And several of these next few slides will actually be talking about um, elements of API management that are really designed to kind of help us with that maintenance and feature capabilities. Two resources that are really kind of interesting to look at in this case are things like the cool URIs referenced from the W3C and the cool URIs for semantic web, also from the W3C. And what these really talk about are how we can structure URLs that can help us, essentially help the future us, right? In terms of maintenance on those URLs and how those URLs may be utilized in things like caching or versioning or other things. And really, these documents provide a set of best practices in terms of how you structure them. So things like here, they were saying, where you have CGI bin or something. Oh, sorry about that. CGI bin in the URL. In that case, you're really kind of exposing infrastructure and implementations that's not necessary. Same thing with the .php. Other types of approaches, may have impact on how the API is utilized downstream as well. So this is really kind of talking about, how we make recommendations on structuring URLs for persistence, simplicity, things like that. One of the things that a URL structure can have impact on is things like caching. Now, when I was going through these slides earlier, I kind of realized that caching is a little bit orthogonal to what we're talking about. We're talking about APIs, we're talking about web architecture, things like how it's structured, the format it's going to return, things like that, versioning. Caching can be something that's really not controlled by the person who is exposing those APIs. But caching could become more and more important, especially as we see some of these multi-agent systems that are going out and collecting information off the web. It may be a situation where we develop very high loads on some of these resources. And caching can help cut back on that, right? Because now you can respond to the API from the cached content rather than having to recalculate it from, say, a database or something like that. And sometimes the URLs that we use can have impacts on that. If we, for example, put parameters in the URL based upon how the caching system is set up, it may not cache that particular resource, or it may cache it for a much shorter period of time than it might a system that utilizes a URL more in line with like the cool URL patterns that are provided. So like these stable identifiers and things like that. The other thing that can happen is that if you're using something like /latest, the cache may see that and say, well, anything that comes to /latest, it will get fed from the cache. But if that's something that's turning over quicker, then you may or may not see that actually served from the new resource from the provider, but actually an older resource from the cache. So there are just some impacts with regards to the guidance for caching. Additionally, there are ways in which we can version APIs. And so this is kind of an important recommendation in that, because you really want to see APIs with versioning in them so that as the provider wants to make changes or as new capabilities are provided or necessary, then that versioning can exist inside there. So there are some types of versionings that we can look at, right? Where we put like things like V1. So this is the Discovery Portal API here. V1 in the query string like this. This is nice because then as we move to something like a V2 or a V3, we can have that persistence occurring inside there. There are also, you could put the versioning inside the header call, a little bit more complex, but does offer some nice capabilities. Query parameter versioning is probably not the best recommendation in that regard, both because of its potential impact on caching, but also because now you've forced the version routing down into your code logic rather than at the URL routing layer, right? So now you have to kind of always have that code looking for what versioning is going on, addressing that, maybe taking different execution routes in order to respond to that particular request. One of the things that I kind of discovered during putting the slide together, which I wanted to share, was that both Stripe and GitHub have a very robust approach to versioning, which was very interesting to see. And there's actually an open source implementation of this model. I won't go into great detail here just for the sake of time, but it was really interesting because what it allowed the developers to do is always be worrying about the latest version and the code base to support that latest version, and then supporting older versions based upon a back propagation, a mapping between the current response model, right? And the older response model. And so it made that kind of maintenance for those older elements much easier in that regard. And that's one of the things that we get out of versioning, right? Is we want reliable long-term URLs that are going to be there because of the potential impact those can have on things like citation and things like that. And also data reproducibility and just the overall fair aspect of the URLs there. So a really important concept within APIs. And for those interested in some of the newer approaches that are coming out that I found very interesting, a link there to an open source reference to that. And if you look for things like GitHub and Stripe with regards to how they're doing their APIs, it was very interesting to look at. Formats. And so this kind of goes back to the earlier slide that I showed, where you saw the JSON coming back from that type of environment. Formats are obviously important. In the context of the metadata recommendations, we really are looking at things like JSON LD. The beauty of JSON LD is that it's extensible. It's web native, allows for easy utilization of dereferenceable persistent identifiers inside the graph. It's also a representation of RDF, which is a graph representation. And while that may or may not resonate with you initially, there's a lot of work going on in terms of knowledge graphs and connecting knowledge graphs into AI workflows that then makes this a very nice kind of early adopter approach to that. And I'll have a little example of that coming up in just a few slides. In terms of data, there are things like FHIR, of course, and other formats that may be very domain specific that are useful to have as return options within your API. And also things like CSV connected with semantics, right? Connected with the vocabulary that allows you then to carry along the context of that information that's inside there. All these are really kind of ways in which we want to improve the usability of that information that's flowing down from these APIs. Another kind of maybe under heralded aspect of the web architecture is the error codes and the error code handling. And so this is very important, and it's really interesting, and I'll show this a little bit later in some examples where these error codes show up and how they work in terms of supporting the kind of web architectural approach, the fairness and things like that of APIs. So just a note there on error codes, right? We're probably all familiar with 404 for resources that are not found. There are popular ones like redirection error codes like 303 or the dreaded 500 internal server error that occurs there. So very important element when you're developing your APIs, an important aspect to kind of maintain there as well. Descriptions. So descriptions are also very important. We want to be able to describe our APIs, and really probably the best practice for that is to be doing that with Open API, and then the Swagger set of tools that go along with that specification. So here's an example Open API document, and then Swagger provides a nice web interface to that specification. But one of the other nice things about this is that it also means that software developers can come along with SDKs that auto-generate interfaces to these APIs. There are also runtime approaches like Bravado inside Python that allow you to execute these types of things. So the description documents are really a resource that you develop for your user community, allowing that user community to be able to access and utilize those APIs all the better. One fun thing that you can start to do with those descriptor documents too, if you're interested, is that you can drop them into things like Claude or OpenCode or Pi, these kind of CLI environments. And they do a surprisingly good job of inspecting those documents and not only generating code, but now the newer ones can additionally go ahead and execute some of those things inside a read eval print loop, or the REPL loop. Basically what that means is that you as a user could find the Swagger or the Open API URL, drop it into something like Claude or OpenCode, and say, inspect this document, um, tell me what it's all about. It can go through and do that kind of things. And then it can actually even construct and issue a query to those endpoints on your behalf inside the AI agent and present the information to you. And I think one of the things that's really powerful about that is it means it's going to really open up a much broader community of users for these types of things. Uh, One key thing to say then too with regards to both just the general open API document and also its utilization by AI types of system is that, really focus on that description field inside there, because the AI systems in particular really love good descriptions. So just a quick um, pull from the notebook. So this is inside the notebook. And I think it was kind of interesting because there was a sequence that really kind of highlighted some of the things that we've already talked about here now. So this is inside that notebook, we're setting up, a URL. So here's the URL that points to that resource, the parameters to that resource, and then submitting that into this. In this case, this is OpenStreetMap's Nominatim, which is geolocating, right? So I put in my address up here, Slater, Iowa, and it returns geospatial coordinates that I then converted to well-known text and also to GeoJSON, just to do both paths, and then put that into Leaflet. And then you can build an interface to that. And so I think it was really just kind of interesting example showing that it's kind of like, we can make these API calls, we can pull back formatted information, convert that to another format, and then display it in a geospatial environment. And there's actually an open API endpoint for that as well. So welcome from Greater Slater, Iowa. You can see where I am located here on the map. At this point, I think we want to take Julie a quick poll if we could, and kind of, because there's just a few more slides left on some deeper topics.
Well, and
And
Doug,
oh yes, sorry.
yeah, well, I know that we have others on the team answering things in the chat or
Oh,
working
thank you,
on
because I don't see the
responses.
chat. Yeah.
But yeah, I didn't know if you wanted to glance real quick and just see if there's anything you wanted to add to that before
Okay, we
we
can do
get
that
into the poll.
while we're doing the poll. I can take a look at it, I hope anyway. I sometimes have, oh, there we go.
Yeah, we've got the question from Andrew, and then the addition from Verasimi.
Oh, is the goal to make URLs PIDs? The
I answered it yes, Doug, so please answer it yes.
okay. I'll reinforce it.
My answer's a little further down.
No, but I mean, it is a good point. Yes, you do want your URLs to be as persistent as possible, right? And this is the contrast, right? When we're talking about the metadata and the APIs here, we're really kind of talking about what one might call a resource-oriented architecture, right? Where the metadata record is a resource and we want to expose that. And we do want that to be persistent. We want that to have long life and long longevity. And so, yeah, I think I would argue that you want those URLs to be PIDs. And that takes on a certain governance, right? Responsibility, a certain maintenance responsibility for dealing with those things. This is actually where some of the other architectural elements can come into play, right? Like 303 redirects, so that if you do have to like migrate what the actual resolving URL for that is, that you can see that you can maintain that, going forward as something that continues to exist on the web. I'll show that. Actually, I got a slide that shows that pretty well here in just a little bit. So, and I don't know if it's a little hard for me to scroll up through here if there's others that people want to call out that I should look at for questions.
No, I think that
Okay.
you addressed both comments. We can circle back after the presentation and see if they wanted to discuss any of the points more, but I think that
That's
was
good.
yeah, that was great. And I guess you're ready for the poll now from
Yeah, let's do
Julie.
a quick poll here before we move on to some of the other slides. And we'll just give a few minutes here for there's just 4 questions. And Julie, I don't know, can you see how I can't see how many people have responded so far, so I don't know where we're at.
We have about 16, 17 responses. It's slowly ticking up.
All right, we'll give it just another minute or so. We're not doing too bad. We don't have a lot of slides left, so we're doing pretty good here, and we'll have time for questions at the end as well.
Doug, I asked Ferasimi, apologies for the pronunciation there, in the chat for an example, and he has a really good example now of his question about provenance, if you want to address that.
Oh, nice. Okay. When our API returns data, how do we include enough information so users understand where the data came from and how it produced, not just which version of the API they're using? Oh, interesting. So, I mean, when you're talking about the provenance of the data, that would probably be something that you would have to incorporate inside whatever that return structure is for that, the data model that you're returning on the data. So, that may be more difficult if you're doing a query and returning results from, for example, a relational database down through. You could put parameters inside the response headers. That may be an approach that could be used for that. If you're dealing with the metadata, of course, you can carry along the provenance inside the metadata, utilizing either some provenance pattern exposed in even things like schema.org or actually the W3C prov vocabulary. So inside the metadata, there are some very formal ways in which you can express provenance for a particular resource. If it's with the return on the data resource itself, that may be a little more thought. Maybe you have to go into that because it's probably going to be some kind of convention that your community is familiar with in terms of extracting that prov. And Julie, why don't we go ahead and see what the responses are here at this point? All right. Oh, we do have SOAP in there. Nice. So most people are doing REST, right? Or maybe don't know exactly what that is. So we do have a lot utilizing Swagger and static documents, right? And so that's great to see. Like I said, I'd recommend for those people who aren't doing any kind of formal documentation right now, looking at things like Open API. I think it's a very nice way to approach that. And then the language model stuff, which is kind of interesting, and we'll get to that here in just a little bit. So great, thank you so much for everyone for your answers in the polls there. So let's continue on. We only have a few more slides left. One of the things I wanted to talk about then was kind of the ecosystem of resources that's available inside NIAID at this time. And so shout out to Ginger. I don't know if Ginger's on the call, but she helped with putting this together. And this is the NIAID Data Ecosystem Discovery Portal. So this is a discovery portal for data, but also has a resource catalog in it. And so in this case, what we're looking at was a query that said, please show me all the resources that have expressed that they have an API. And so that's the query that's taking place here. And you see 17 out of 41 resources that are cataloged have discoverable APIs. That's for the ones that are being cataloged. And you can also see the ones that where the APIs are being leveraged for processing that metadata into this discovery ecosystem. And the primary way that metadata is currently being expressed is plain JSON. And as you saw in the earlier examples I gave too, and as noted here, import and some others are already expressing JSON LD to represent their metadata. And there's also XML and CSV formatted metadata records. And so, that just gives you an idea of that. And then where the APIs don't provide the full metadata coverage, she does note that they do some site crawling in order to fulfill that. So this is a very nice resource to visit to see, who else is also using APIs, maybe someone to interact with and collaborate in that regards. Now, one thing I wanted to do was show this, and I'll spend just a little bit more time on this slide maybe than I do on some of the others. This was actually kind of fun. So I actually took the resources that were expressing APIs as denoted by the discovery portal, and I then retrieved the JSON LD metadata that's associated with them, and then made this plot and visualized this. And so I picked out some of the elements. This is not all the elements, of course, inside the metadata, but I picked out some of these elements and showed them in this graph. And what's nice about this is that, and one of the reasons that we really kind of advocate for JSON LD is not only is it an extensible way to represent metadata and a web native way to represent metadata, but it is a graph inherently, right? It is a representation of RDF. And once you do that, then you can start doing things like these visualizations or graph analytics to kind of see what some of the more interesting elements inside the whole ecosystem of metadata may be like. And the one that caught my eye, of course, is this one that was right here in the middle, which is this little red dot here with lots of connections to it. And so I found out what that was, and it actually turns out it's this ontology topic 0622, which is very nicely done because if you'll notice in this curl representation down here, this accessing this particular resource does a dereferences as a 303 redirect to a resource that describes what that is. And this is a very good practice in terms of exposing these types of resources on the web. It's what I alluded to earlier to the question that, if you can maintain that particular topic, 0622, as a persistent identifier, then dereference it back to something that the human can use or the machine can use, it makes that maintenance on that URL much easier. And so it turns out that I can go to this particular concept topic, and this is genomic, which is probably, and I'm not a domain scientist, but probably is fitting as one of the more key shared concepts within this little graph, this little network that I generated. And again, this took advantage of APIs, right? I could pull the information that I needed, query for all those JSON LD documents, collect them. I collected them into a simple pandas data frame, fed them into a graph, and then provided the visualization here. And actually, this code is inside that notebook as well, if you're interested in that. So of course, you can't go, you can't have a presentation anymore without talking about AI. And when you're talking about APIs and AI, probably the thing that's going to come up most is Model Context Protocol. So this is the most popular way that you see this kind of connection of exposing information for the language models, for the agents. It really is an API. It's I call it API by convention because it's got a very strong requirements in terms of how the API is structured, what URLs are available, and how you interact with them. And so Model Context Protocol, this whole topic could be a whole presentation in of itself. So I'd be very careful what I say here because it could just go on forever. Do you have a link that's in that that collection of links that's shared? And this is at that GitHub repo where I talk a little bit more about Model Context Protocol, provide some links out to some interesting resources that. So if you want to learn more about this, you can take a look at that link and see what you may want to see inside there. I did say, just provide a little more detail here. You know, do you need Model Context Protocol? Maybe, maybe you don't, right? It's not a given that you do. If you're dealing with communities that already are fine with the APIs that you're exposing, you may not need to go to Model Context Protocol. But if you want to have something that's a little bit more aligned with how the language models work, of how the workflows work, agents work, that's more involved there, then Model Context Protocol may be a good approach for you. Again, there's some details about that at that resource I mentioned. I would just caution that don't just take your existing APIs and wrap an MCP wrapper around them because you really haven't accomplished much for the AI community, and you've just given yourself a little bit more maintenance to worry about in that regard. So, really kind of look at what are some of the unique capabilities of Model Context Protocol in terms of how it can offer some of those services. And there's a list of some MCP systems that you can play around with there as well. So we're at the quarter mark. You've listened to me for a long time. So at this point, I'm going to say that we can skip this slide because this slide is really just saying what are the elements of FAIR that are associated with the APIs. And we've really been seeing that along this whole way in terms of discoverability, design, the return formats and things like that. So I'll just say we've been here, we've done this slide. And so we're also basically at the end here. You can probably tell I got a little tired too, putting this together. But APIs really just kind of good for humans and machines, right? And so they provide shared context both for humans and a shared execution context for machines, and especially some of these kind of emerging agent-based systems that are coming up in that regards. So we have some upcoming webinars. Christine, I don't know if you want to speak to these at all.
Yeah, sure. Yeah, sure. So we do continuing in the series that explores the NIAID blueprint on April 29th, also at 12 p.m. Eastern, 9 a.m. Pacific. We'll have one on kind of wrapping some of these topics together and how to use these different tools to show the impact of your data repository. And then on May 27th, we'll delve into the core metadata schema, or called out in the blueprint, the minimal metadata schema, those common elements that are suggested to be in there. And through all this, we're very interested in your feedback about the blueprint. This should be a living document. It should work for the community. And so please do follow the links that we gave you in the chat, and we'll also follow up after this webinar with more information so that you can register for those. We have and more on that series. Okay. And of course, we do want to thank our all of the community that helped contribute to the blueprint and the Fair Landscaping Project that predated that and informed the blueprint. Um, and I think with that, we can go to questions and hopefully answers and discussion. And if you want, Doug, you can stop sharing.
Okay.
I think we're all friends here, and people should feel free to raise their hand. If they're comfortable, turn on your video and ask your questions. Well, and let me ask, first of all, for those who ask questions already, please let us know if you'd like to revisit any of that. Okay, so first up, Dasha, please.
Yeah, thanks so much, Doug, for a wonderful presentation and for all those resources in the GitHub and in the chat. I guess if you had to pick one thing in this presentation that you think NIAID should prioritize in the next year or couple of years, what would it be?
Oh, wow.
Yeah, it might be a
Um,
hard.
maybe not so hard. I mean, especially when in the context of this, in the context of the blueprint, we're really talking about metadata. Um, I really, I mean, I've been working with knowledge graphs for longer than I'll admit to, and it's kind of fun to see them coming back into popularity. And so I really think that that alignment to a JSON LD representation of metadata provides the ability to, form the knowledge graphs that you can work from. There's a lot of work going on in other communities with knowledge graphs, and there's a lot of work going on inside the AI community in terms of leveraging knowledge graphs in terms of like GraphRag, but also other approaches. That means that if you can begin to construct that catalog of resources in a graph-wise manner, I really think that's a powerful, powerful capability. So yeah, I'd go with that one. Final answer.
Thank you.
But also, like, small moves are important. Even just having an API that's documented and versioned
Oh,
would,
sure, right.
I mean,
And I
that
mean,
on the other
early
end
on,
of the
yeah,
spectrum.
and early on in the presentation note that, we went to that import page and we were able to pull out that JSON LD, you know, from the actual web page, right? From the DOM on that. And so that's wonderful, right? That's a web architectural based way to expose structured data on the web, and then provides that kind of capabilities that we saw at the end then in terms of graph analytics or visualizations or things like that.
John.
Yeah, if I could add on to that, I think one of the main points that surprises people a lot that comes up that's really high value is the importance of keeping the APIs persistent. That a lot of us implement them the first time, and then a year later, 2 years later, we think, oh, actually, this would be a lot better like this, and we implement a new thing. And I was fascinated by your example where as you change the API, it can actually keep track and map back to the old versions of the API, which is a fascinating opportunity. But whether you do that or not, I think it's really valuable if people are able to think about we're creating this thing and we would like the people to develop tools that work against this thing. So we should keep this thing stable. We should not
Yeah.
have this thing disappear in a year and waste the time of all those people who develop tools against it.
Yeah, I mean, definitely the cool URIs and the versioning, I think, are very powerful.
Yeah, cool URLs.
One of the things that I enjoyed about making this slide deck and all the help that I got from the Gopher community and others, is the kind of the stuff that was coming out of what Stripe and GitHub are doing with that pattern and that open source thing. That was really impressive, because it allowed the developer communities to focus on developing the new capabilities, but then they essentially backported through mapping the response data model, right? So the way that system works is really kind of by maintaining just the response data model on the old versions and then backporting it from the new versions through mappings. Anyway, very fascinating, and so worth a look if you're interested in APIs, I think. Oh, and I never mentioned, but on the notebook, if you got a problem with with the Nominatim API, I forgot there's a one query per second rate limit on that. So if you got an error code on that, just try it again if you're interested in seeing it actually work.
So did anyone follow along with the notebook, and do you have any feedback? I don't know if I've ever had a webinar where we had that option before, and I really applaud Doug for trying to come up with something that satisfied someone who wants to go through it line by line. But that was really fun, Doug.
I enjoyed making it, if nothing else. So.
Well, and let me ask too, did people have more questions about MCP? I mean, you must be getting asked about this or, wondering where this all fits. And I know Doug had to be very vigilant and not including too much about this and to tank the rest of the discussion. But if people want to talk more about that, I mean, we do have a few more minutes and we could answer any questions you might have. I know also, Doug, you had some examples of APIs from the NIAID community. If any of you are on and you're representing repositories or data resources and you thought, you could have included ours here, or we also do this, like, please do let us know. We want to make sure that our examples are as up to date as possible and representing the full breadth of the community.
Yeah, there's really a lot of wonderful APIs that I could have picked from. So I hope I didn't. I hope if I didn't pick yours, you don't feel offended, because there's a lot of really good ones out there, and some nice descriptor documents and everything.
We've got a question from Drew in the chat. He said, you mentioned potential loads on APIs from LLM and agentic systems. What do API developers need to consider in that space to keep resources available to as many people as possible?
No, I mean, it's a great question, right? I mean, one, and there are some things that I didn't mention inside here, some gaps in the presentation that needs to be brought up, and I think your question does a good job of bringing them up. Obviously, you can do things like rate limits, like I just mentioned on that Nominatim API has a rate limit of 1 per second, right? Those types of things can help. Also, the caching can be a big benefit there, right? Because typically your caches are much faster, right? And so if you have some cached content and it has a long life, such that you can reliably cache it for a period of time, that can help a lot with those kind of environments. The other thing is that I didn't mention, which is a gap, and I probably should try and add that to the repo, is that authentication and how you do that with things like OAuth and those types of approaches, or API keys and things like that. That's going to be a big deal too, because as these agents start coming up, then how do we properly provide them with authentication and things like that? So yeah, but in terms of the load that may exist, I think really beyond just trying to be as efficient as possible, maybe being able to take advantage of caching is good. Maybe if you have options in terms of the return, in terms of the response data model, being able to try and keep that as tight as possible, right? So you're just transferring less and being able to deal with it a little bit quicker. So a lot of this, your best practices in terms of API optimizations in that regards.
Doug, quick follow-up there. Are GraphDBs generally more susceptible the way that triple stores have been to queries that can just take the system down because they're so complex?
Yeah, no, that's a good question, right? They can be, right? It's easier to denial of service a graph endpoint probably than most. Although there's a lot of really nice graph systems that are coming out that are very performant, and also a lot of them now, because of that, have the ability to limit how many responses go, or even can pre-evaluate the Sparkle query to see if it can be processed in a sufficient amount of time, or timeouts. So it's becoming less of an issue. Big shout out to Clever, though, which is a fantastic triple store in terms of performance.
And Doug,
Ginger,
question from Ginger. Go ahead.
How is user APIs being MCP and other agents tracked? Oh, that's a really good question, right? Um, so you're talking about like what if model context protocol is calling the APIs, tracking them. That's interesting, Ginger. I mean, maybe the agent string might, you know, be different, but that then you're kind of depending upon the people who wrote those to provide you an agent string that maybe gives you that kind of information. Um, wow, that's a good question, Junior. I can't say I can think of how you could distinguish an API call from, you know, someone doing something on a notebook versus an API call coming from an MCP, other than maybe if you knew about the network, you know, if you could track the networking and you see huge numbers of them coming from a single source, you might start to question what that single source is. Um, yeah, interesting.
Well, we'll take that as an open question
Yeah,
to
sorry, Ginger, no
noodle
definitive
on.
answer for you on that one. So good question.
Well, maybe that's a good place to leave things and just to show even when you're the expert like Doug, there are still things that we're discovering because the
There's
technology evolves and we make it work for our use cases and our needs the best we can.
there's
So
a
if you do
lot
have
out
any,
there. Yeah.
yeah, and there's a lot to know. So thank you so much for tuning in for this hour. Thank you to Oddset for co-hosting and sponsoring this webinar. And we continue to be interested in your questions about this, as well as your feedback on the blueprint, specifically this today on the recommendations on APIs. But please keep in touch and we will follow up with links to the slides and other materials shared. Take care, everyone.